Welcome students. Today we are going to deal with our chapter 10, secondary growth. If you compare the stem of monocot and dicot, do you feel any difference? Yes, the stem of monocot is soft whereas the stem of dicot is very hard and woody. Not only stem but also the root of dicot is also hard and woody. The reason behind this hardness is secondary growth. In monocot, secondary growth is not usually happen, whereas in dicot, both stem and root undergo secondary growth. But if you look, the bamboo and the palm, which is under monocot plants, they show hard and woody stem. What is the reason behind this? I am giving you this as an activity. Find the reason. Now we can look detail about the secondary growth. Plant group normally have two growth. One is primary growth second one is secondary growth. In primary growth, it is by the activity of meristems, especially apical meristems, and it increases the length and width of the root and stems. So, this type of growth is called primary growth, whereas we can call it as longitudinal growth. Primary growth also called as longitudinal growth. But in secondary growth, the thickness of the stem and root is increases. So, it is increase in thickness. This type of growth is called secondary growth. It is also called as latitudinal growth. Latitudinal growth. So, plant organs show primary growth and secondary growth. In primary growth, lengthwise growth is happened. It is due to the activity of meristems. It is also called as longitudinal growth. Whereas in secondary growth, the thickness is increased. It is also called as latitudinal growth. Now, we can go detail on secondary growth. In our previous chapter, we detailedly studied about the primary growth of both monocot as well as dicot, stem and root. Now we are going to discuss about the secondary growth in dicot as well as some and gymnosperms. Usually, secondary growth in dicot and gymnosperm is brought by two lateral meristems. So, two lateral meristems are responsible for the secondary growth. First one is vascular cambium and cord cambium. So, these are the two lateral meristems which is responsible for the secondary growth. In this chapter, we are going to discuss as two sections. First one, secondary growth in dicot stem and secondary growth in dicot root. First, we are going to study secondary growth in dicot stem. Secondary growth in dicot stem. We already said that the secondary growth is brought by two lateral meristems, vascular cambium versus co-cambium. So, we can discuss about vascular cambium. Vascular cambium is nothing but the lateral meristems that produce the secondary vascular tissues. The lateral meristems that produce the secondary vascular tissues. So, what are secondary vascular tissues? Secondary vascular tissues are nothing but secondary xylem and lateral nervous stem which produces secondary vascular tissues are called vascular cambium. The secondary vascular tissues are secondary xylem and secondary phloem. Okay. Then origin and formation of vascular cambium. The origin and formation of vascular cambium. Origin and formation of vascular cambium. This is a vascular bundle. Okay. A strip of vascular cambium that is originated from the procambium is present in between the xylem and phloem of the vascular bundle. So, this is the vascular bundle. This is phloem. This is xylem. So, a strip of cambium. A strip of cambium which is originated from the procambial cell. Okay, so this is a vascular bundle. A strip of vascular cambium is present in between the phloem and xylem of a vascular bundle, whereas this strip is believed to originate from the procambium. This is called vascular cambium. Vascular. This is called the vascular cambium, or we can call as intravascular cambium. Vascular cambium also intravascular cambium. Okay, so these are all about vascular cambium. This is the vascular bundle. In vascular bundle, there is phloem and xylem. In between the phloem and xylem, there is a strip of vascular cambium which is believed to be originated from the procambium. It is called vascular cambium. It is also called as intravascular cambium. Now, we can see what are intervascular cambium. So, this is a single vascular bundle. If we consider many vascular bundles, so if we can, this is the cross section of the stem. If you consider this is the cross section of the stem, there are so many vascular bundles are there. So, these are the vascular cambium inside every vascular bundles. So, here there are parenchyma tissues. We know that here there are parenchymal tissues. Okay. Okay. So, the parenchymatous cells of the medullary rays that become a line form. These are the parenchymatous cells of medullary rays. So, that become a line. Okay. So, the parenchymatous cells in the medullary rays that are in line with the vascular cambium. So, it is in line with the vascular cambium inside every vascular bundles. This cambium is called as intervesicular cambium. So, this is called as intervesicular cambium. Okay. So, in the medullary veins, the parenchymatous cells are arranged in a line to the vesicular cambium of the vascular bundles. These are called the intervesicular cambium. So, the intervesicular, so this is intravascular, this is intravascular cambium, and this is intervesicular cambium. So, the joining of intervesicular cambium and intravascular cambium on both sides to form a continuous ring, it is called as vascular cambium. So, actually this is not joined now. So, when this intervesicular cambium and intravascular cambium join to form a ring structure, it is called vascular cambial ring. Actually, this is called the vascular cambial ring. So, I think you all are clear. A symbol, each vascular bundle containing a strip of cambium is called vesicular cambium or intravesicular cambium, and the parenchymatous cells of the medullary veins, they are in a line with the vesicular cambium or called as intervesicular cambium. Both the intravesicular and intervesicular cambium joins to form a continuous ring is called vascular cambial ring. So, these are about the origin and formation of vascular cambium. Origin and formation of vascular cambium. Now, we are going to see the difference between intervesicular cambium and intravesicular cambium. Intravesicular whereas intervesicular. Okay. So, we already discussed about what are intravesicular and intervesicular. Now we can point out the difference. The first difference is intravesicular cambium or vascular or vesicular cambium, which is present inside the vascular bundle, whereas intervesicular cambium, which is present in between the vascular bundles. So, the cambium is present inside the vascular bundle, whereas in intervesicular cambium, the cambium is present in between the vascular bundle. Okay. So, intravesicular cambium, the cambium present inside the vascular bundle, whereas intervesicular cambium, it is present in between the vascular bundles. Next, we already said that the intravesicular cambium is believed to originate from the procambium, whereas intervesicular cambium, it is originated from the medullary veins. So, it is originated from the procambium, whereas intervesicular cambium, which is originated from the medullary veins. So, these are the difference between the origination. Then, intravesicular cambium initially forms a part of primary meristem, whereas intervesicular cambium, from the beginning itself, it's a form of part of secondary meristem. So, intravesicular cambium, we already said in the primary structure, so it's a part of primary meristem. Whereas intervesicular cambium is originated at the time of secondary growth, so it is a part of secondary meristem. So these are about the difference between intravesicular and intervesicular cambium. Now we are going to move the organization of vascular cambium. How they are organized? Organization of vascular cambium. organization is very simple. Actually, the cells of vascular cambium don't fit into the usual meristematic cells. Why? Because usual meristematic cells are isodiametric cells. They having dense cytoplasm and large nuclei. But an active vascular cambium requires cells with large central vacuole surrounded by thin layer of dense cytoplasm. So, active vascular cambium requires large vacuole and dense cytoplasm. So, an active vascular cambium requires a large vacuole and thin layers of dense cytoplasm. So, usual meristem cells are isodiametric cells. So, they have large nuclei and dense cytoplasm. A normal cambium cells cannot fit in there, so that it requires a large central vacuole surrounded by thin and layer of dense cytoplasm. The most important character of vascular cambium is the presence of two initials. Actually, vascular cambium contains the presence of two initials. First one, fusiform initials. Second one, ray initials. There are two types of initials that is present in the vascular cambium, that is fusiform initials whereas ray initials. Fusiform initials are vertically elongated cells. They give rise to the axial system of secondary xylem and secondary phloem. They are vertically elongated cells and they give rise to the axial system of secondary xylem and phloem. Okay, they are called fusiform initials. So, based on the arrangement of the fusiform initial, there are two types of vascular cambium. First one is storied vascular cambium and second one is non-storied vascular cambium. Storied vascular cambium. Second one is non-storied vascular cambium. So, based on the arrangement of fusiform initials, the vascular cambium is divided into based on arrangement of fusiform initials. Based on arrangement, the vascular cambium is divided into storied vascular cambium whereas non-storied vascular cambium. Now we can look what are storied vascular cambium and non-storied vascular cambium. In storied vascular cambium, the fusiform initials are arranged in tangential manner. That means the fusiform initials are arranged in horizontal tiers with the end of the cells of one tier appearing at approximately the same level, that is in a tangential longitudinal section. Those type of arrangement is called storied cambium. So, So this type of pattern of arrangement is called storied vascular cambium, that is longitudinally arranged in a tangential manner. Tangential longitudinal section. So this is storied vascular cambium, whereas non-storied vascular cambium are strongly overlap at ends. They are strongly overlap at ends. They are called non-storied vascular bundles. They are called non-storied vascular bundles. Here is the fusiform initials. In the fusiform initial, the ends are aligned longitudinal are called storied vascular cambium, whereas the end overlap is called non-storied vascular cambium. Next one is ray initials. Ray initials. Ray initials are nothing but these are horizontally elongated cells. We already looked that the fusiform initials are vertically elongated cells, whereas ray initials are horizontally elongated cells. Horizontally elongated cells. They give rise to ray cell, whereas fusiform initials give rise to the axial system of secondary xylem and phloem, whereas this ray initial give rise to the ray cells and it forms the radial system of secondary xylem and phloem. It gives rise to radial system of secondary xylem and phloem. In fusiform initials, it gives the axial system of secondary xylem and phloem, whereas in ray initials, it gives the radial system of secondary xylem and phloem. So these are the difference between the storied and non-storied vascular cambium, whereas the fusiform initials and ray initials.